this test. Okay, so first thing we're going to look at is drawing the bonds. So if you want to make yourself a little table like this, we're going to do several and you can just add down on the bottom. This was the written part. You need to be able to draw the Lewis dot. So when we look at strontium, strontium is in the second column. That means it's going to have two dots. So we go SR and the dots should be opposite each other. Iodine is one away from being a noble gas, and noble gas has 8, so iodine has 7. So we pick a different color, and iodine would have 1. That wasn't a different color, but okay. I chose a different color, but it didn't choose one for me. Would have 7. If I can do it here. Okay, so if you look at this, strontium has 2 to give away, but iodine only needs 1. So we actually need, sorry, there's a hair in my face. We actually need 1 more iodine. So I'm going to draw 1 more iodine in. I love this today. And when I do that, it also says draw the Lewis dot of each element needed and show the electron transfer. So I want to show the electron, and I wish I could change colors, but it's not letting me. Show the electron transferring to iodine. Okay? Then when you go and draw it, so everyone needs to either be 0 or 8. So by moving each of those electrons to iodine, we make it SR is 0 and I is 8. So over here when we do it, the bracket SR will actually be in the center, and it will have a 2+ charge. Been fighting my board all morning. Okay, a 2+ charge. Iodine, since these were actually opposite each other, they'll come in opposite each other. So I put an iodine on this side. Oh my gosh. This keeps doing this. We'll bring, okay, I'm bringing up the other thing. We had to do this last period. I don't know what is going on with my PowerPoint, but we'll just bring this in and work on it right here. Okay, so we had, okay, and now it goes away. I am really having fun with this thing today. Just wanted to make this skinny so we could see what we had already. Okay, so that's what we have already. So we would draw strontium in the middle. Now I can do colors. Whoops. Strontium in the middle with brackets around it with a 2+ charge. Then we would put iodine on either side with 8 electrons around it and a negative charge. Then to write the chemical formula, for every 1 strontium, I needed 2 iodines. So the formula I would write SrI2. That would be full points. Okay. Going to the next one, and I'm just going to bring up that whiteboard again really quickly because then I can use different colors and make it bigger. Okay, so here we need to cesium and bromine. So cesium, if you look at cesium, cesium is in the first column. It would just have 1 dot around it. Make sure if the second letter could be an element by itself, like S could be sulfur, make sure it's less than half of the size of the other one. Okay, so there's cesium. And then we need bromine. So bromine has it's 1 away from being a noble gas, so it has 7, so we would put 7 in. Okay. Then we need to show what's happening, so I'm showing this electron being transferred down to here, because they each only need to give 1 away or get 1. And then for the charges, I would just say, okay, cesium lost an electron and became a positive, and bromine, I would show all the electrons gained 1 and became a negative ion. Then I just needed 1 of each, so I would rewrite the formula over here, CH2 SBr. Okay. So going on to the next one. Again, I'm going to bring that up. So we're still working with ionic. Ionic is the give and take bonds. Okay. So gallium, find gallium. How many does gallium have around it? Gallium is Ga. So it's right here, number 31. How many would it have around it? 3. Good. And we draw it in a triangle, right? Because they want to be as far away from each other as possible. And then we look for sulfur. How many does sulfur have around it? 6. Okay, so 1, 2, 3, 4, 5, 6. Now, gallium wants to get rid of 3, and sulfur only wants to take 2. So this is one of the ones where we had to get to a common factor of 6, right? So I'm going to need 2 galliums to get 6 electrons, right? So I'm going to draw another gallium. And I'm going to need 3 sulfurs to be able to take on 6 electrons. And then I've got to show where they're going. So here goes 1 electron right here. Here goes another electron right here. Here goes another electron right here. And here. And here. Whoops, it's supposed to be right there. Ignore that other dot there. And here. Okay, so I've shown where they go. And then just like that program that we did, we're going to draw them over here as gallium is going to be in brackets with a 2 plus, and gallium's going to be here with a 2 plus. And then we've got 3 sulfurs that are going to be attracted to them. We're going to have a sulfur here with all its dots around it, with a 2 minus, whoops, gallium's 3 plus, sorry, because it gave off 3. And we're going to have sulfur here with 2 minus, and we're going to have sulfur here with 2 minus. So what's the final formula? How many of each did you need? Yes?
So whatever the plus is how much you give away, right?
Yep. So we needed 2 galliums, so we're going to write it Ga subscript 2, and we needed 3 sulfurs, so S3. Okay, so that's the ionic one. Now, you also need to be able to do the covalent one. Covalent was with the shared. Let's see, was that a covalent? I'm going to skip this last one and do a shared bond because we're running out of time. So on a shared bond, again, I'm going to bring up my extra piece of paper because this is not being nice. With a shared bond, you still are going to do the Lewis dot of each element. Okay? So we're still going to do phosphorus. Phosphorus has how many around it? So put a little thing there because we got a little bit different thing going on here with covalence bonds. So make sure you divide that so it's covalent. So phosphorus has how many around it? 5. Good. So 1, 2, 3, 4, 5. Iodide, it already told me how many I'm going to use. I'm going to use, whoops, let's go back. Come on. Love this, not. Okay, iodine has how many around it? Iodine's 1 away from being a noble gas, so it would have how many around it? 7. 1, 2, 3, 4, 5, 6, 7. Now, the difference in this, I can stop right now and I can write the formula. So I'm going to write the formula over here because it said phosphorus penta-iodide. So that means I have 1 phosphorus and 5 iodines. Okay, so now I've got to figure out how it's going to go together. Okay, so phosphorus wants more than iodine does. Phosphorus wants at least 3. But remember, phosphorus and sulfur are the party animals of the periodic table. So they'll actually split these ones that have already been paired up and go to one by themselves. So we're going to put phosphorus in the center. And it's going to, since it's going to bond with 5 things, I'm going to just put 5 lines out from it right here. it actually gets a shape like this, like a triangle paper with a line through it or a pencil through it. And then I'm going to put my iodines on each of these, and I'm going to show the other 6 electrons. Because remember, a line represents 2 electron pair. So this one, we're not showing a negative and positive because a covalent bond is a sharing bond. So we're drawing the shape. Okay? So ionic bond we draw the positive and negative because they're electrostatically attached. But covalent bond, we just draw the shape. Okay? We're going to do one more of these, and then I'm going to go on to the types of reactions. I didn't know how much time we'd have or how long this would take, and with me having computer issues, it's not helping. Okay, so we're going to go do phosphorus well, let's do something else besides phosphorus. We just did phosphorus. Guess one. Okay, germanium. Oops, that's not one I wanted. Okay, germanium, hydrogen trifluoride. Take each one of them separate. So germanium, Ge, how many around it? 4. It's in carbon's column, so it's going to have 4 around it. Okay, hydrogen, how many around it? 1. And fluorine, how many around it? 7. 1, 2, 3, 4, 5, 6, 7. I can go ahead and now write the formula. That's always a good thing when you're on the covalent bond. So let's write it. Over here it says germanium. When I give you a chemical formula, write it in that order. Okay? So it says germanium, hydrogen, trifluoride. So how many hydrogens? And I actually should have said mono, but we'll pretend. 1 hydrogen. And then trifluoride would be F3. Okay? All right, so germanium is going to go in the center. And we have its 4. And then I look at it and say, okay, how am I going to put the rest in? Well, hydrogen just needs 1, so I'll make it go here. It doesn't really matter where I choose to put it. Fluorine, I have 3 of them, and each of them need 1. That takes care of it all. So I just put it in. Fluorine, 1, 2, 3, 4, 5, 6. And the one I had in there, 7. 1, 2, 3, 4, 5, 6, 7. And a fluorine here. 1, 2, 3, 4, 5, 6, 7. Okay, so the difference between ionic and covalent, ionic you're going to give me the brackets, you're going to give me the charge because it transferred. Covalent, you're just putting it together so you get 8 around it, or for hydrogen you get 2 around it. Okay? That's the only difference. The covalent bond tells you exactly what the formula is, so at least do that. At least do the Lewis dots. Each of those boxes are worth 2 points. Okay? Now we're going to go forward and talk about the types of reactions. So, this is with your worksheet. I'm going to do a couple with you. You have to finish the rest of these. So if you don't understand, come in and sit down with me. The first one is sodium fluoride. This is type 1. To remind you, type 1 is column 1 plus 1, column 2 plus 2. You've got the slide, boron, aluminum, gallium are plus 3, zincs plus 2, and silver's plus 1. These have a specific charge. They always have that charge. So all I have to do is say, oh yeah, sodium's in the first column. It would have been a plus 1, right? Ugh, I'm going to have to bring that thing up again. Dang it. Okay, sodium would be a plus 1, and fluorine would be a minus 1. So I would put them together as NaF. Okay, I'll just put this off to the side. So Na, which is a plus 1, F was a minus 1, already adds to 0. I would just put NaF. Then we get to where we have a polyatomic. So I skipped down. I think this is the last of that section. Can you see it? Lithium iodate. I think it's the last of that section. Lithium is a plus 1. Iodate is what I would get from the back of the periodic table. So anything that ends in 8 or ite, like a fight, is going to be on the back of your periodic table. So look there. Only exceptions that are not elements are hydroxide and cyanide. Just remember, if you see hydroxide or cyanide, it's on the back. And then you look it up. So iodate happens to be IO3 with a -1 charge. Again, plus and minus, already taken care of, so I just smash them together and write LiIO3. Make sure you put the caps on top and bottom of the iodine. Okay, we're going to go to the next type. So this is just a quick review. I'm going to give you a little bit of each type so you can sort of see. The next type that it talks about on your paper is the type 2. Now remember, type 2 is all about the D, the F, or the lower part of the P, not including our metalloids, which are boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. So that little zigzag staircase doesn't count there. These are ones that can have lots of different charges, and so we want to be able to write and tell what charge they are. So, let me slide this over a little bit so you can have it. So copper 1. The 1 tells me the charge on copper. So copper is a +1. Oxide, what's oxide? Oxygen. And what does oxygen have for a charge? How many away from a noble gas is it? Oh, how many away from a noble gas is it? 2. So it's going to be a -2 because it's easier to get to 2 than give away 6, right? Okay, now this does not add to 0. I really need 2 coppers with a +1 to add to 1 oxygen, right? So I would write it Cu2O. Okay. The second one is down farther. I can't remember exactly where in your thing, so find it. Tungsten 5 or 6 phosphate. I think I did the first and the last of each section, so you can sort of see. So tungsten 6 means that tungsten, which is W, has a +6 charge. Phosphate, I'd look on the back of my periodic table for phosphate, and it is PO4 with a 3- charge. So what's the common factor? What do I want to get both of them to? 6. So tungsten's already there, right? I just need one more PO4 with a -3 charge, right? So that means I have 2 PO4s, and they're a group, and I need them as a group. So when I put it together as a formula, I go tungsten, parentheses, PO4, close the parentheses, and then put the 2 to tell me I need 2 of that group. Okay? All right, let's go on to the next type. Next type is acids. So really quick review, acids. If it's a binary, meaning just 2 elements, there means there's no oxygen. It will say hydro. That's my key. If it says hydro, I know it's just hydrogen, one other element. I don't have to look at the polyatomics. I just know hydrogen, one other element, and I balance it. That would be like this bottom one, and that's not on your thing. So if you want to put it off to the side so you have an example or put it down at the bottom, you can. So hydrochloric acid means I have hydrogen and what? Chlorine. Chlorine's 1 away from being a noble gas, so it's -1. Hydrogen's +1 always. And with acids, all you're doing is deciding how many hydrogens to put with whatever it's with. Okay? So if chlorine's a -1, I only need 1 hydrogen, so it's HCl. So I'm not going to write that right now, but that's what you would write. Okay? HCl. For the other types, we've got to sort of look. Remember, if it's ite, it came from OS, we're going to get in a fight, right? So I look on the back for the OS ion, and I add how many hydrogens I need to make it add to 0. If it was an ic ending, remember Thanksgiving dinner, it came from 8, so I look on the back of my periodic table, and I find the one that's with 8, and then I add as many hydrogens as I need to balance it to 0. Okay, so let's try these two. Phosphoric acid, what does it come from? Phosphate, right? It came from 8. So I know I have a hydrogen because it's an acid, and then I know I have phosphate, which is this one. How many hydrogens do I need to add to that phosphate to make it add to 0? Well, if each hydrogen is a +1, and I have a -3, I need to add 3 of them, right? So I need to go like this. But that's not how I write it. How do I write it? H subscript 3, saying there's 3 hydrogens, PO4, and there's no charge now because they're balanced out. Hypochlorous acid. So chlorous came from, I wanted to get in a fight. Oh, us, we're going to get in a fight, right? So chloride is what I'm looking for. Again, I know it's an H+, right? Because it's an acid. I just have to look on the back of my periodic table and say, okay, what's hypochlorite? Well, hypochlorite happens to be ClO with a -1 charge. How many hydrogens do I need to balance that out? I did just what's there, right? +1, -1 already adds to 0, so I just smash it together. So acids, that's just all about how many hydrogens do I need to add to whatever it's with to make it add to 0. Okay? All right, last type. Whoops. Maybe it didn't go. Maybe it was at the first and I skipped over it. Yep, right there. Covalent type. So back up to the very top. Sorry about that. I skipped over that. This is the part that, remember I said, caution, caution, don't name all of these this way. Well, you guys did on the test. So you got to remember, you can only use this if it's on that staircase: boron, silicon, germanium, arsenic, antimony, tellurium. It's a staircase that comes down. If it's on that staircase or above. The only 2 that are not right on the diagonal are germanium and antimony. Okay, they're sort of supporting the staircase. Okay, so as I look at this, carbon disulfide, let me show you what you need to do. A lot of you were doing silly stuff because you were trying to balance the charges. On this one, there's no charges. It tells you how many of each you do. Carbon, I put a carbon. Disulfide, oh, sulfur, there's 2. Done. I don't have to worry about charges. I don't have to worry about anything else. But what I was seeing people do is they would go, carbon has a +1 and sulfur has a 2-, so that must be C2S. No. Okay, it tells you how many each one. Yes?
The 2 in the sulfur comes from how far it comes?
Nope, it comes from right here. Whoops.
Oh.
See what I did? Okay, so it comes from right here, the di. So when we do this last one, I'm not going to bring up that again. Oxygen, what would I write down? Just 1 O. Difluoride, what would I write down? F2. So it's OF2. So the prefix goes with that element. That tells me how many of that element. Okay? You guys were trying to balance charges again with that one. Or you were trying to, I don't know. Okay, remember that on the type 2, that Roman numeral tells me the charge on the first one. I think that's where you guys were getting off on the other one. We're thinking, oh, well, it had a di, so that must go with the first one. It goes with what it's attached to. Okay? So this is what you need to do. You need to finish the worksheet, attach the notes that we took today. That finished worksheet and your notes will be your ticket to get your retake. Okay? Retake the test Monday after school or Tuesday before school at 7:15. Okay? So you have about 6 more minutes. Work on one. See if you can do it. On the back side of this paper are where they're all mixed up. So they're not separated into types so that maybe you can work on, trying to figure out what type is what. Okay? And if you need help, I'm here. Let me stop this video.